Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
Okay, question one is if everything works well, okay, how predictable is the behavior of the device for landing? Okay, and it is, and it's relatively predictable within a set of dispersions and inputs that are provided by the atmosphere and other things that are outside, that are not controllable. That's why the ellipse is 20 kilometers long and 7 kilometers wide. You know, if you told it exactly where you were starting and exactly where you were in, the question would be, how come guided entry doesn't put you on the spot every single time? And the reason is because there's dispersions in the system. There's noise on the radar signal. There's dispersions in the wind models. There's a bunch of things. Okay, there's noise in the IMU. So there's a bunch of things that will stack up either in your favor or against you and will move you around. So it's statistically deterministic. There's a 99% chance it'll be inside the ellipse. Okay, if everything works right, that's the story. Facts on the ground. Okay, the 7 minutes of terror are for the non-predictable parts of this. Okay, I mean, we have a big mantra: test as you fly as you test. EDL is a classic example of you can't do that on Earth. Okay, we do a whole bunch of testing and we stitch it together. But it never fired 70 pyros in 7 minutes on this thing in an atmospheric environment like Mars while we're going down at between 10 and 0 Gs, right? We haven't done that. So is there something, we've analyzed the hell out of it, is there something that's hidden in there, something we've missed, some subtlety of the interaction? You know, electronics get become lower and lower voltage electronics. Does that make a difference to us? You know, all those questions try to be answered, but they're never answered until you actually fly a system through the environment that's the target environment. And that's the terror part of the 7 minutes. Is the part that you know
Yeah, so basically, what really distinguishes this mission is the geology of the site that gives us this ability to look at what could be hundreds of millions or even a billion years of the history of the planet. And so in comparison to Spirit and Opportunity, where we looked at a few meters of stratigraphy here and a few meters of stratigraphy there, now we've got hundreds to thousands of meters. And by analogy, our understanding of the Earth, if you ask, what are the great instances in Earth history that allow us to understand the tempo, say, of biological evolution, we know it's the combination of genetic possibility and environmental opportunity. So, you get that information about environment by decoding the stratigraphic record. And the more of it you have, the better off you're going to be